Your brain has the amazing ability to identify these distinct images as the same dog, while recognizing the difference between one image and another. But how can a computer do this? Many computer programs are great at completing a specific task, but they lack the ability to learn from their mistakes like humans can. A field called machine learning aims to solve this problem and primarily uses a framework called neural networks. Neural networks consist of many nodes called neurons, which are grouped into different layers. Deep learning refers to networks with many layers. These neurons get their name from their similarity to neurons in a human brain and consist of inputs, weights, a bias, and outputs. For example, I want to make a neural network that classifies benign versus malignant tumors. The inputs are images of tumors, and outputs will be 1 or 0, representing malignant and benign diagnoses. Inside a neuron, each input is multiplied by its respective weight and summed together. Weights are like the synapses between neurons and signify the importance of a particular input in determining the output. In this network, weights on various attributes like the tumor's shape, size, and color will give those attributes different amounts of influence on the network's diagnosis. A constant bias value can also be added so that the neuron's function will output a lower or higher number. Currently, neurons can output any value, but we want the network to make a desired prediction of a 1 or 0. To fix this, a normalization technique called an activation function is applied. One common activation function is the sigmoid function, which limits very negative numbers to 0 and very positive values to 1. In essence, a neuron is a function which takes in the combination of weighted inputs and spits out a value between 0 and 1. The outputs of one layer of neurons influences the next layer and so on, and the neural network's weights and biases are essential for transforming an input into an accurate output. But how do we know what these weights should be? At first, the network knows nothing about tumors, so we can feed it hundreds of tumor images labeled as malignant or benign and teach the algorithm to recognize patterns between images and their diagnoses. Fine-tuning the weights and biases to get more accurate results is called training the neural network. To train it, we need a cost function that will tell us how well the neural network performed with respect to its error. The error is found by subtracting the network's prediction output from the actual output in the training data, evaluating how far it was off from the target. A high cost means that the neural network is very inaccurate, so we want to reduce the cost as much as possible. By graphing a weight of the network as an input to the cost function, we can find the weight value that gives the cost function a minimum value. Picture it as a ball rolling down a hill. Each time we run through another training iteration, the neural network will adjust its weights down the hill slope and will settle at the lowest point over time. After repeating this training process for thousands of iterations, the neural network will learn to adjust the weights in each layer so that there is almost no error between the predicted and actual diagnoses, meaning that the algorithm can accurately classify the tumors. That's deep. Learning. The beauty of neural networks is that they can be applied to almost any data set, and with good enough training can generate very accurate predictions. They can be used for marketing analytics, medicine diagnoses, image identification, chatbots, driving cars, and even for rocket engine testing and diagnostics. The ability for humans to learn and adapt to change is one of our greatest strengths, and that's why I think neural networks are truly an algorithm for anything. Thanks for watching.